Hi, folks. Welcome to our stream for today. I'm going to be showing everyone how we can build a full stack app in Go. I know some folks of you are watching the live stream, but we're also going to have a ton watching the recording, so I hope you're ready to dive in. We're going to give it a minute for people to join the stream before we start off. Great. So getting started today, I just want to make sure everyone can first go and download the hack pack that I created. You can do that here. So make sure you head over to the GitHub and download the hack pack that's on screen right now. This hack pack is going to be the starting place and where we're going to be going through this presentation. Make sure you look at it. It has all the important info you are going to need to be able to get working on your project immediately. Everything from your backend, your front-end database, and even how you're going to be able to get it deployed onto the cloud. So we're going to give it another few minutes for people to join before we start. And so we have the presentation up now. We'll give it another couple minutes for people to join. I hope you folks are ready to be able to ask questions and, learn to really build a project, not just for this hackathon, but for future hackathons as well. I'm sure what you're learning today will be incredibly useful, so hopefully you're able to take as much out of it as I'm giving. We'll get started in 1 minute. All right, cool. Just sent out one last message to everyone. We're going to wait for everyone else to filter in. I know there's folks on the recording. We're going to get started really shortly, and we'll be off from there. Awesome. So make sure you head over to the GitHub that's on screen right now, Allen Kaplan Hack Pack Go. From there, you can clone the repository we'll be using, or you can even fork it, or just download it as a zip and start building from there. It's going to be pretty straightforward, and we're going to get started again in another 10-ish seconds. So I hope your folks are ready to be learning everything about Go, and also creating a full stack web app and what's needed to deploy that to the cloud. Thank you, Aditya. All right, great. So we're going to get started here. If you folks have any questions at any time during the stream, please don't hesitate to let us know, and we'll make sure that we can answer whatever questions you have. So without further ado, let's get it started, and I'll lower the music a bit. Great. So today we're going to get started on how to build an app. The few things that you'll need to have ready to go are Go itself downloaded, which you can go get at go.dev/dl. You're going to want to download Docker, which is going to be a containerization platform allowing you to easily deploy it to the cloud. Make sure you have an IDE of your choice. I recommend JetBrains' Golang, which has a free educational license, and alternatively, you can use VS Code with plugins. Finally, when you want to be able to put this on the cloud, you're going to need a Google account with the Google Cloud account, and then as well creating a Google Cloud project. So those are the important things to keep in mind when getting started using this hack pack. Some of my personal suggestions on how you can succeed include getting a sketch and mock-up done of your front end and what you kind of want before you start, and as well knowing what the data models you'll be working with are. So maybe what attributes a user will have, or anything else within your problem domain. So if you're working on an app for cars, it's probably important to know what attributes and fields your cars are going to have. If you want to use user accounts as a part of your solution, you can definitely make a basic user model, and you don't need any fancy implementation or authentication to get it going. The only thing I would say is if you're already experienced with that or you're experienced with Firebase, it's definitely great to include Firebase auth. So getting past our prerequisites and some of my suggestions, let's dive more into it. Great. And so let's open this full screen. Make sure you can follow along with the presentation that's in the chat. So some of the basics of Go for folks who haven't used it before. Go is a procedural language, and that essentially means that although it might look more similar to the way you're programming in Java, sometimes it's not object-oriented. It's not as rigorous, and it lets you kind of code things in an order and just follow the order that's given. Some of the resources that I think would be great if you're new to the language are the Tour of Go, which is a really quick overview of the language and its tooling, the Go web examples on how to do everything like dealing with JSON, templating, dealing with databases, and of course, Go by example, teaching you how to use some of the Go syntax with tons of examples, all hyperlinked in the presentation here, or feel free to Google them. So we're going to be creating HTTP JSON REST API. That's a lot of acronyms, so let's break it down. An HTTP JSON REST API is essentially four different acronyms coming together. We have an API, or the application programming interface, which we're using to kind of say we have different endpoints that we can hit from front end, be it within our own app or another app. It is a form of REST, or representational state transfer, because we're going to be turning things from Go models and Go code into JSON. And the JSON we're using, or JavaScript object notation, is really easy to read by any front end, be it a mobile app or React Vue app. And finally, this is all happening over HTTP, specifically HTTP 1.1. So putting it all together, it's a JSON REST API running on HTTP and in the Go programming language. So a lot of acronyms coming together, but it's more simple than you think. You have two options when developing this full stack app. One, you can keep it all in Go and use Go's templating and rendering engine for your HTML that you're going to be serving. But alternatively, if you're on a team with maybe more people, some people who really want to build a React app, you can totally separate your front end and run it with NPM or Yarn, and then just make requests to your Go backend. And if you have any question on specifically how to do that, we can talk about it towards the end of the presentation. And you can also ask for help during the hackathon weekend. As well, we're going to be using Docker-compose, so we can kind of run a DB locally. We don't have to download Postgres or run it locally. We'll just use Docker-compose, and as well, it'll allow us to run the container. And finally, we're going to go over how to deploy the container, and it's basically two steps. One is creating it and then pushing it to the artifact registry, and the next is setting up Google Cloud Run to actually use it. So all of these together is what we'll be going over today. So in the hack pack that you've downloaded, hopefully already, or will do soon, you can see that it has a bunch of different folders in it. Namely, the important ones we're going to be going over are the API folder, the CMD folder, the DB folder, models folder, and as well templates and static folders. The core of the app runs in the CMD folder, and we're going to go over what's in that main.go file soon. But essentially, what you need to know is that's the entry point for the application. So every application has to start somewhere, and generally it's that main method, and that's in this command directory in main.go. Next, we have API, which is one of the arguably most important folders, which is where you're going to be keeping your server and your API endpoints. This is really important because this is where all your logic for the application should go. So let's say you're trying to find out what tax bracket a person should be in, you're going to put it in the API layer and not the DB layer. talking about the DB or the repo, this is where you store your data and connect to the DB itself. So if you want to persist data either in your app or in a database, you can do it. We're going to do it in the DB layer, separating our API logic from our DB logic. And finally, with the core of the program, we have the models, and these are the things you're going to be using, storing, and interacting with. We're going to dive deeper into what models look like and how to make them, but essentially, with a Go being a typed language, we need to declare all the formatting for things that'll be going. So a user has a name, they might have an address, they might have an age, and those are all models, right, to build that user model. And of course, we have templates and static, which are going to be there for serving your HTML, your JavaScript, and any relevant CSS. Some additional things to go over as well, you see on the bottom half are just files. We have our .env for environment variables, which are useful in Docker-compose or the Go app. We have a git ignore file to ignore any sensitive files like our .env, which might have keys to our Cloud SQL. We're going to have our Docker-compose.yaml, which will be for running our DB and as well can run a backend or the whole app. And as well, we have the Dockerfile, which is the instructions on how to build that Docker image. There's a file going to be called Go mod when you create a new Go project, and this is Go modules. If you ever need to clean it, you can run Go mod tidy. When you add modules that Go install or Go get, that you'll be putting them into the Go mod automatically. And then as well, finally, the last thing here is the makefile. And the makefile has a bunch of commands for you to easily do everything from building the Go app, building Docker containers, running the DB, everything. And we're going to go deep into the few commands that I've already put there for you. So like I mentioned, I want to take a look at how that works in the core. And really, let's start with cmd main.go. Essentially, we can see that we start with a function main. We use this go.env library to load our environment variables from the .env file. Then we take some of those environment variables and we put them into a config for the DB. And then we're going to create our DB and the server. And you can see that happening just there. And so this is all happening on the main launching point, the entry point of the application in main.go. The next thing on the right is what comes after that, and it is creating a router and adding endpoints. So endpoints are going to be something that you're going to be wanting no matter how you're building this application. So you can actually handle some of the logic being getting models, adding things, editing things, any sort of thing that needs to deal with the backend will have an endpoint. So the first thing we do is we declare our loading our HTML glob essentially. And the reason we're saying that is because we want to load our HTML files because our HTML files are an endpoint themselves. And then we're going to load all our separate endpoints. And so you can see we're adding /app for all these different things where you can get, post, put, delete, and you can see there's the get to dos handler, post to dos handler, and these are all the handlers that are going to handle the request, and they're defined in API server.go. So we'll go over them in a second. As well, you can see we set a port and then we run the router itself. So you can change the port with environment variables, which could be really useful if you're running other apps in tandem with each other. So taking a look at API server.go and how to add your own endpoints, there's a server struct and kind of a constructor for it. So you can see server struct has just a repository, which is the data for the server, and also a new server function. And all that does is return you a new server, which will be really helpful because that's what you're going to be doing everything on. So as you go back, you can see that we add in our main, we have the new server, and we call it over here, which defines creating a new server. And then for every request, we can create our endpoints with different handlers. So you can see all the handlers, all they do is take in a context, they return nothing. And through this, we can connect to our DB layer, execute anything there, and return a response. So all we're really doing here on this basic, CRUD app is creating or getting some models and then returning it back to the front end. Pretty straightforward, but has a lot more room for complexity as your requirements for your project change. If you have any questions, please feel free to put it in the comments. And if you're watching this asynchronously or just a bit delayed, you can also reach me on Discord at alphakilo0001 or just Allen Kaplan on the yuHacks Discord. Next, we'll look at the data layer, which is repo db.go. This is creating the DB and defining its functions, and as well the actual methods of those functions to interact with the database. So both sides are the same file, just one after another, cut down to be easy to read. We can see our creating of the DB pretty easily by creating the DB URI, which is essentially where you need to connect to deal with the DB. We open a connection with Gorm open. We migrate the models we have so we can make sure they're in the DB. And then we can return the database itself. We also have a repository interface, and that interface defines all of the functions that our DB has. So interfaces are a great way of abstracting out, what is the concrete implementation. With that in mind, we need to fill all of those implementations in, which is the right side of the screen. So you can see those 5 functions on the left under repository interface are defined on the right side with get to do, get to dos, create to do, update to do, delete to dos. Everything with Gorm with db.db, you can see first find updates, creates, and deletes. Pretty straightforward and very useful. You don't need to write any SQL here, although you can with the .raw method. You can just easily use Gorm and the models you've already defined to easily interact with the DB and get what you need done. Great. So is there any questions? All right. Seeing none from the chat, we're going to move on and take a look at a bit more. So the next major part of this is Dockerfile and Docker-compose. And so I'll just bring up the screen alone for a second. We can see that with the Dockerfile, we have 3 main areas. And this is because it's a multi-stage Docker build. And I wish you could see my hand motions as I'm describing this. Within the first part of this Dockerfile, we're just basically copying our go .mod over, and we're downloading all of the dependencies. Then we copy in all of the other folders, including our envar folder, before we send it over to the build layer. In the build layer, we simply build it, and then we go to the next layer, which pulls that binary. That's why it's the bin build the stage. We pull the binary and we run it. So this way, it's really lightweight and leverages Go as a compiled language to avoid needing to run something like npm. So the next part is Docker-compose, and Docker-compose is essentially the methodology for running our Docker container and especially our DB and having them connect together. So you can see that on the right side in the Docker-compose, there are services, and we named 2 services, backend and DB. The backend image is the hackpack-go image. We expose port 8080 so we can access it locally, and then as well it be connected to the DB. There are some environment variables you can open up on your own computer that essentially tell it what the Postgres information is. And you can see the Postgres information right below with exposed ports 5432. So we're able to connect to it locally if we want to do anything with the DB. So setting up the cloud is a 3-stage process for this project. You're going to want to set up 3 things. Google Cloud SQL, easily done by going to Google Cloud Platform SQL and clicking on Create Instance. I suggest creating a Postgres instance when you're given the option. Once it's created, and it takes about 5 to 10 minutes, which is why we're not going to do it live, you're going to get the URL. And from that URL, you'll be able to connect to it from your Go app directly. Even if you're running your Go app on your computer, it can be really fun just to deal with a cloud database. The next thing is once we have our image, we're going to eventually need to push it to the artifact registry. So make sure you create a repository for a Docker image once you hit the Create Repository button, and then you're going to get the use the project ID and the endpoint you'll need to push it to. And then finally, to run your app in the cloud, you're going to use Google Cloud Run. And you can hit Create Service, and you're going to get a few things pop up. The main important things you want to do is you're going to want to select the container image you're using. We have the test container here, but once you click select, you can see from Google Artifact Registry your containers. You can give it a maximum number of instances of 1, so you don't get charged for some reason since the default is 100. You want to make sure it's allowing all traffic, because we want it to be public, and as well authentication, make sure it's allowed to be authenticated. So we have Steve asking in the chat, what's an artifact? And that's a great question. An artifact is just a generic name for the output of any program, essentially. So sometimes when you're making a Go app natively, you'll just create a binary, and that's the artifact. In Java, you'll create jar files, which are the jar artifact. And in even npm and Node, you'll create npm artifacts. So artifacts are just the general term for something you're creating at the end of a build process. And in our case, that build process is a Docker container. So our artifact is a Docker image that we are putting up there. And then finally, the last things you might want to add are environment variables. So maybe you have different environment variables for when you're deployed versus for when you are developing locally. So you can make sure you set them here in the Google Cloud Run definition. So how do you use these all together? Well, I broke the makefile down into two main areas. On the first, we have the Go tooling, and the other side, we have the Docker and cloud tooling. Within the Go tooling, we have Go build, run, lint, and vet. You can see pretty standard. Go build will build it. Run will do the build, will build the container and also run it. Lint will format all your files to the Go standard, and vet will check for any errors. So if you were to run Go vet before Go build, it would tell you the errors before you build, which can be really helpful in saving your time without needing to build something to check for errors. On the other side of things, we have build up down. Build is really important because it'll put together the project so you can actually run the container. You can run everything with make up, and that will run the Docker compose. You can take everything down with make down, which is Docker compose down, or you can even just run make db, which will start only the db of the Docker compose. Finally, we have the push command, and this is how you're going to be able to tag your container with the Google artifact registry ID and the name, and then push it up to the artifact registry. So you could do the same thing on Docker Hub. You can do the same thing with the Elastic Container Registry on AWS. But essentially, the idea is if we're running it in Google Cloud, we're going to need to be able to get the artifact up there as well. So some of the questions that I get a lot of the time are, can I put DB stuff in the server layer? That is to say, do I need to create that DB folder and the repo folder and do everything there? You don't need to do that at all. And if you really want, you can actually just straight up put your DB stuff in the server layer. Personally, I think it's harder to debug that way, and it'll be easier if you separate your DB and your server, since it's not any much more code. And if you're working with multiple people, it can let you handle different things. People ask me, I'm new to Go and how can I debug? I would really suggest to use the debugger in Golang and VS Code, being able to set breakpoints and inspect current variable values at that thing. But there's always the classic fmt or format.printf, print that you got here and print that variable and what the value is with %v. Can be great to also help you. Maybe you're trying to find out where you're getting a nil pointer, and you can solve that with that. So another one I get when teaching people this is, can I just run React and use Go as my backend, right? It's really easy to code out a backend with Go, even though you can do it in JS. It's nice when you're developing separately. And so, of course, you can just make sure if you're running two applications, they're on separate ports, so like 8080 and 8081. And then if you want to deploy your app, you will have two options. One, you can change the Docker file I have, and I can actually give you examples of how to do Docker files with it to package your React app into that Docker file, or you can create two separate instances running it. So that means, you would be requesting from one URL to another URL, be it inside or outside of your virtual cloud. And so you can totally use React, and I'm happy to help anyone who wants to do that. That being said, that covers the presentation portion of what we have here today. So before we move on to some of the code, I want to know if there's any questions from people. We'll give it another little bit for any questions to come up. There are definitely tons to take in this project. It's not always the most simple to learn new tooling, but it can be really beneficial for your growth, and that's all about what hackathons are for. Awesome. So let's dive into Go. I forked and cloned. Can I run the app without installing Go and Docker? You can't run the app without installing Go or Docker. You'll need to install one of the two to be able to run it. You can download them both pretty easily, and I really suggest you do. I could build the app for you if you tell me like what your operating system is and stuff, and build a binary. But you will need one of the two to be able to run it. Just like you need, Python to run Python. You'll need to be able to at least download Go to build the binary, or download Docker to run a container. So it'll be important to do that to get it done, but they are not difficult tasks. I think they're pretty streamlined. So let's pop open Golang here and we'll take a look around. Great. So I want to just dive deeper into some things here. So one of the things to be aware of is that the delimiter is changed. If you see this r.delims on the router, that's because I'm using Vue in my example in the index.html, and Vue also uses double curly braces, while Go templating engine also uses those double curly braces. So with r.delims, you can actually change what Go uses for its templating engine, so it doesn't conflict with React or Go. So it's important just to be aware of that. And one change also for my slides I noticed I didn't update is the repo is created just here. I was using this fake DB before. One thing you should know, if it's a hackathon, you're not maybe comfortable with using databases yet, to just use something in memory. Yes, every time you restart the app, you lose what you had. But when it comes to making something, it's not always super important to have that persisted data. So what I did here is I created this fake database. And fake database is essentially just a map of the ID of a to-do to the to-do itself. And we can go look at what the to-do model is. A to-do model is just the Gore model, which has an ID created, updated, and deleted at, as well as a name, description, status, and just some tagging to say this is what it should look in JSON, and if it's empty, don't include it. So with the fake DB, all we do is we can just create the new fake DB. We can get to-dos with using the map. We can return all to-dos by ranging through the DB. We can create to-dos, etc. The cool thing is, because this conforms to this DB interface, this repository interface, you can actually totally swap this out. So if I'm in main.go and I have new DB config, I could also as easily do repo is repo.new fake DB. And that way, you're actually now using in memory, which can be way easier for prototyping, and you don't have to worry about, dealing with the database, dealing with running it in Docker or anything. So what I'd suggest is, if you're not comfortable with databases, a great way to start is by using this repo here. It will totally save you time in not running a database and getting started a bit quicker. And like I said, it works perfectly because they both implement this repository interface, and new fake DB does return a repository, since fake database implements all these methods. I do recommend doing the tour of Go if you're unfamiliar with some of this, but I think over time it'll come relatively simply, because you can see creating a to-do just adds another one of another ID, updating a to just replaces the current one, deleting to-do is pretty straightforward. So hopefully that will be helpful if you folks don't want to deal with an actual DB. Let's take a look at some of the front-end code I used to implement this project in. So we're using Vue here, and you can see I'm actually bringing in Vue and Vuetify, just with the CDNs forged from JS Deliver, and their delivery network already holds all these things like Vuetify. So you can see that this to-do app has a few buttons that are pretty basic, and I can run this to view it. If I run this app, we'll run makeup. Great. And so that'll build in the background. But essentially, what we have here is a form, first of all, to add new to-dos, and you can see that we have everything here. We have the name, description, edit status, and a table. And then for every to-do in to-dos, we just add a row, a TR, the table row with the ID, name, description, status, and a little edit button, which allows us to edit the to-do from up top. Bring in some other things like Tailwind and Axios for some of the easier styling offhand. And as well, any of the methods that are used here, like get, post, put, are all declared here. There are much more intricate apps and front ends you can build for an application, but this is a simple example where we have an index.html that handles all the logic with Vue, and then the API itself is able to serve it with the index handler where it returns index.html, and you can see that title to-do tracker when it appears in your browser. So pretty straightforward. And again, the reason we can run this index.html is because we do load it with the load HTML glob, which loads everything inside templates. So through having things in your templates folder, you're actually able to run them from the Go app. You don't need to run anything else. You don't need an NPM or a Yarn app for a simple front end, which a lot of the time for a hackathon is all you need. I wish I could have known not to build something so complex early on. So hopefully this will be helpful to you folks who are still learning. Again, you can find this repo up to date on the GitHub, on my GitHub, Allen Kaplan /hackpackgo, and all these slides are in the GitHub repo for you to open, and as well they're in the chat of the YouTube comments for people viewing this on YouTube later and want to scroll up. Oh, I see that the Dockerfile needs to be renamed as repo. Cool. Well, I'll give it another couple minutes for any questions. Otherwise, everyone can have some time back to get back to the hackathon. I'm happy to give any mentorship or one-on-one support with any teams which want to learn how to use these technologies. I think it's pretty straightforward, and hopefully with a little bit of motivation, you folks will be able to get started on making a full stack app, being able to deploy it to the cloud, knowing that these are the steps right here. So you can see it's just building the bin now stage. Yeah, it's always the longest on the first build before anything is cached. Great, and we can see it's finishing up right here, just pulling the last few things from the Go image before it can build. We also fix that up for you folks who will be making your own project. So you can see you'll just need to be able to edit these where it says your project name to be able to take advantage of using the makefile that already exists. Pretty straightforward. So you'll be able to build your container and then just run make push and push it up to the Google artifact repository, or registry rather. If you have any questions, feel free to ask it now, and it'll also be available later on. And like I said, the Docker container building the first time was always the longest. If it hangs kind of like you're seeing right now, it's probably working. It's just a bit slow at finishing up. But you can always system exit with, Control or Command C to be able to head outside of this prompt. So we'll give it just another couple minutes here for any folks who might have questions on this. Hopefully you folks liked an approach that was more slide based this time. I know I've done workshops coding things out live. If you folks have any feedback, you can always reach me over Discord. You can also make sure to follow me on Twitter at Allen Kaplan. You can add me on LinkedIn. Just make sure you add me from yuHacks and I'll accept your invitation, no issue. If If you have any questions about cloud development outside of Go, I'm also happy to ask. Yeah. Cool. So if there's no other questions, then I'll make sure to push any of the changes I made upstream. And I hope you folks are, excited to be building this hackathon weekend. So you can just see, even some of the changes I made recently just before this presentation broke things a bit. So I'll make sure to push the changes I just made to fix it up. But you can see now everything's building normally, using the cache layers, so we get to skip all the time. And now you can see it's fully built. We can run makeup. You can run Docker-compose. Let's run Docker-compose up manually, just because I know I made some changes in the makefile, which make it a bit weird. But you can change it with whatever your project name is. So you can see creating our network, building the backend. Let's call this image to do. Great. And ports are allocated because it's already running. Yeah. So you can always run Docker-compose PS. You can see what's up already. So you can see, yeah, you can see it's a bit broken here because of the changes I'm making. So we'll make that to do, and we can do Docker-compose up backend, and it'll bring up the backend. Can you maximize it? Oh, sure. So you can see the different things that are running here in the Docker container. So I have a bunch of things that I realize are up because of my actual company. I'm running things on the same ports, but I can bring them down. So you can do Docker kill, and you can just pass it to container IDs or names. So Docker kill PSG will kill that Postgres container, and then I'll just do Docker kill radar backend, because I'm running my own servers right now. Docker sometimes restarts your containers automatically, which I didn't realize what was happening when I was testing earlier. So I'll run Docker-compose up. It'll start our Postgres, creating to-do. There you go. It'll launch. And now you can see that the server itself is up. We've loaded HTML templates and everything. And so you can see both the logs of everything are running side by side through the compose. And then when you go to localhost 8080, you'll be able to get what you're looking for. So you can see, let me switch my screen share really quickly. And so you can actually see that, it brings up the actual web app at localhost 8080. I see you can't see the URL bar, but everything comes up that's running from the Go app itself. And you can go, you can add application, you can hit the edit button, etc. I see some of the things are a bit wrong here, but it's a starter pack for you to build anything off of. Change the UI. I didn't want anything too fancy people couldn't understand at first. So pretty straightforward here. That you can just see the front end that's running on the back end application. And so, if I do application, I just say like, this is a to-do. So, laundry, like, colors, and then, not applied. You can see we get a response from our back end itself, which is really great to make sure that everything's working, and then we can get everything back itself. And so just to switch back to my screen with Go, just switching back to the back end, we can even see that we are receiving requests from the front end. So if you folks are running into any issues, I really recommend making sure you just print out statements to help your debugging. It'll save you time, and you can just follow along with the requests that are coming in here. Again, if you want to make changes to the front end, it's pretty straightforward and can just be done here. All you need to really do to get that done is just to make sure you can create these functions to whatever you need and set the fields of whatever you're doing to what you are your data models are, right? Because that's really all it is the data models. So yeah, you can change here name, and this is description. I see that wasn't changed from before, but everything else comes together quite nicely, and you can see that we're able to get everything we want. And so if we want to get everything, we can use this Axios get over here, and we can actually do like localhost 8080/todos. So I was using JSON placeholder while making this. And then again, when you want to run everything, you'll just run make up, and it will build everything. I have a bit of placeholder stuff, so it's going to error right now, but essentially that's that. All you really need to do is you can run your get functions, and then you can do whatever you're doing. This is console logging it, but you can make your front end with axios.post. From there, you can post to whatever your front end is located at. So this here is localhost 8080/to-do, and then you can include your body of your payload. So essentially, you'd be wanting to add your JSON stringified new to-do. So pretty straightforward, but your front end is really something I'd say that's up to what your personal comfortability is. I know I did Vue here because that's mine, but I know it's not a lot of other people's. But it is pretty straightforward with all the functions being here. And then just right now it's console logging and alerting instead of posting it, because you can actually do that with curl or with Postman tooling. So what I would also suggest, not something I dive deep into because it's not a back-end tutorial, but being able to use Postman and curl to just interact with the backend allow you to kind of circumvent that front end. And if you're a team on a hackathon with maybe 1, 2, 3, whatever it is, backend developers, you don't need to rely on the front end to test your code, which is something that a lot of the time when you're developing Express, or a Python app, you end up relying on having to use that full stack to debug. Well, with this, you can separate your development from your front end and back end and allow your hackathon team to move a bit quicker, knowing that you don't have to link things up until maybe tomorrow, or even the day it's due if you're really late. And it saves time, saves your frustration, and you don't have to argue with people saying, when can you fix this, or, push it up to main, or you broke something else. So that's my 2 cents on that development side. Cool. Are there any other questions you folks might have for me before I guess we can call it the end of the workshop? Stephen Bailey, I know you folks are in the chat. Thank you for watching. Yeah, I'm always, trying to learn how to give workshops, and I'd love to know what people are interested in and want to learn. Try to, do something that's a bit more open, and obviously having a presentation for the first 20-ish, 15-ish minutes, to kind of explain everything without needing to dive into code. Great. Well, if there's no questions, then I'm gonna go make myself some lunch, and then I'm off to another meeting. I have had a great time running this. I hope any folks who are watching right now, or going to be watching on the live streams, will get as much out of it, as I got when I was first learning. So make sure that you head over to my GitHub, um, and you download the hack pack, and I'm just pushing up right now some of the changes I made right now. But feel free to use it. Let me know if there's any issues, open issues in the repository, and maybe I'll get to them, this weekend. But otherwise, I hope you can also reach out to me anytime. I'll make sure I can help you with what your project is, not just from the engineering perspective, but the design and product overall. So have a great rest of your day. I hope you have a great time starting your hacking at yuHacks. And for the folks watching later, I hope that it was a great stream for you as well. Peace.